Um, Good afternoon, everyone. This is Rajalakshmi. The final paper topic which I have chosen for the course project is object-oriented design principles to design microservices. About this paper, in this paper we are going to learn how efficiently we can apply object-oriented design principles and models to design a more efficient microservice. In order to do that, we are going to see how can we apply the solid principles and how can we use the object-oriented programming features like encapsulation, polymorphism, and inheritance uh, to the microservice design, and how can we use the UML diagrams like use case diagram and class diagram to design a microservice. So each of this model is going to be explained with an example so that it will be more clear on how can we use the object-oriented principles. So regarding the related work, like there are not much paper have been published to make use of the object-oriented principles to design microservice. Still, I could find some of the papers which are related to this topic. The first one is designing the architecture for airline system, which is based on the UML diagram. So in this paper, the author has suggested that uh, we can use the class diagram of the application to design the microservice. Hence, the microservice is becoming more efficient and it helps them to receive a more profit of the airline system for the group customers, like it can be an organization, government, or it can be institute. So that is like the airline system can it can gain more profit while redesigning the microservice architecture by applying the UML diagrams. And the second paper is UML profile for domain-driven design of microservice. This paper says that when the microservice is decided to design based on the domain of the application, in that case, we can use the UML diagram, its elements and the constraints to design the microservice architecture. Hence, the architecture is becoming more efficient. So, and these are the some related papers. And what is the new paper is going to be that we are going to use the OOD principles to design the microservice. So it is not yet published, and this probably kind of a new paper for this topic. And throughout the paper, we are going to talk the um, uh, application that is a restaurant application. So if you see in the diagram on the right side, these are all represents what are all the services available for this restaurant application, and all these services are being exposed through the API gateway, and from that gateway the clients like the application which is running on the desktop or the application running on the mobile, they are accessing through the API gateway. So we are taking this restaurant application for the example of each of the principles. So first we are going to see about the solid principle. How can we use the solid principle to design the microservice? So there are 5 principles under solid. The first one is single responsibility principle, also called as SOP. It says that whenever you are designing a software class or module, it should be focusing on a single or a specific purpose. For example, if you are designing a class for an employee, all the elements inside the employee clause should be related to the employee, and there shouldn't be any other property or functionality which are not related to the employee. So the same principle can be applied when you are designing a microservice. So if you are designing a microservice, it should be focusing on a specific functionality. So for example, in the restaurant application, we have the order service. So how can we apply the solid SRP principle to the order service? So consider the situation like at present, the order service is creating an order object or a record at the back end. Like whenever it is receiving a request to create an order, it will go and check for the existing order. If the existing order is not available with the current ID, it will create a new order. Suppose it finds a new sorry, suppose it finds an existing order. In that case, it will go and update the existing order. So here, if you see a single, the request is made for creating an order, but what the service is doing, it is going and updating the existing order if it is available. So we can modify this kind of service. Like inside the order service, consider this diagram. We are separating the module, like we are creating a module to create only, it is focusing only on creation of the order, and updating order, this will do the updating job of the order, and deleting order, this will go and delete an existing order and verify the order existence. This module will focus on whether the given order is existing in the database or not. So we are separating the module like this, and then now we are receiving the same request to create or update the order. So we are modifying the order of the service call. So first I am invoking the verify order existence. If it says that that order is already existing, then I will be invoking the updating order with the current details. Suppose if the existing order returns false, then I will go and invoke the create order service. So there it will be creating a new record for that order. So we are separating the modules. Each module is focusing on a single task, and what on the top of it, we are just added some reordered way of service call. So in this way, the SRP makes this application more maintainable and reusable. And the next solid principle is open closed principle. As we already know about this principle, like whenever we are designing the software entity, it should be open to add a new features and functionalities, and it should be closed to modify the existing functionality and the features. So the same principle we can apply for the microservice design. So whenever you are designing a microservice, it should be extendable. Like if the customer or client would like to add a new feature to the existing service, it should support it. But if there is a situation to modify the existing service, then it should not be supported by that microservice. So how can we attain it? So, for example, we are taking the catalog service in the restaurant application. So we are taking this catalog service. We'll see how can we apply this open close principle to this particular service. Uh, just consider that right now the catalog service is displaying all the catalogs, that is the menu items and the categories in a single language, that is a common language. Maybe it's English. Suppose in future, the customer or client would like to display the menu items in native language. That is, if a customer who is browsing through the catalog from France, then the catalog should be displayed in the language of Spanish. Suppose if the customer is browsing through the catalog from India, then the catalogs or the menu item should be shown in Hindi. So based on the location, the language of the menu item should get changed. In order to attain this new feature, we are not going to disturb the existing catalog service. We can just add a new service which is focusing on processing the language. So on the right side, this outside application is accessing the catalog service and reviewing the menu items in English. And then it is accessing the language processor where the menu items which are in right now in English language is being transferred to the language which is requested by the outside application. So the open source principle is being followed in this design because we are not disturbing the existing service and we have added the new feature to the existing service. And then the third principle is mixed code substitution principle. This also we have idea as our professor explained about it. So, excuse me. Whenever we are designing the inheritance, like we have the base class and subclass, the subclass function should be substitutable for the base class functionalities. Like suppose we have a base class which is supporting some task or functions, and in the future the client would like to attain the same function with a different task to be done. In that case, we can derive a new derived class which is going to inherit the existing base class function, but it is going to add some extra stuff in the derived function. So in this case, we are not disturbing the base class, and whenever the client would like to add the base class function, he can access the base class function. If the client would like to access the derived class function, he can also access the derived class. So this principle can be applied to the microservice design as well. So as we have the catalog service in our restaurant application, so here uh, we have the regular catalog, which is displaying all the menu items and for the regular customers. And now the client would like to add a new feature that we would like to have a separate catalog for the customers who are all making order through online. So for that, to support that feature, we are going to inherit the regular catalog service and making a new service called the online catalog. This will have all the functionalities which are already defined in the regular catalog, and each of the functions will have the features that is needed for the online customers. So now the client, if you would like to browse through the regular catalog, you can go ahead and browse the regular catalog. Suppose if the client is willing to view the online catalog, he can also do that job. So in this way, we are making the microservice more scalable and reusable. And the fourth solid principle is interface segregation principle. In this principle, like instead of designing a single interface which is exposing more of the services, we can separate the interface, and each of the interface will be focusing on a specific task. So that is what interface segregation principle says, that each of the we can design more interfaces, and each of the interface is going to do a specific task. So as well, the interfaces are designed at the abstraction level. So it means that the clients who are all accessing the interfaces, they just know what kind of services are supported or provided by the interfaces, and they don't have any idea how those services are implemented and how the task is being completed. They don't have that idea. So the clients should be able to access the abstraction level of service, and each of the service should be focusing on the particular particular task. The same principle can be applied to the microservice. Like they can design a microservice. Inside the microservice, it will have a lot of logic uh, to be implemented. But when it is exposed to the client, it just exposed through the interface. Means that it just have the name of the service, and the client will access the service through the interface, and they don't have any idea that what is implemented inside the service. So for this, we see the example like the order service in the restaurant application. In the existing application, the order service is also doing the job of payment. Whenever the user is making an order, it is taking care of the payment of the order. So this design can be redesigned as per this diagram. So here we are splitting the order service and payment service. This order service is going to focus only on order. It will go and create an order or update or delete. Those operations can be done inside this order service. And for making a payment, this order service internally it can invoke the API of the payment service in order to make a payment of this particular order. So I mean, in the future, if you would like to modify some of the or some of the features in the payment service, we will not disturb this order service, and we will only work with the payment service. So in this way, it is more scalable, and since the edge of the service is exposed through the abstraction, it is more secure because the client or outside application who is accessing this service, they don't have any idea of the internal logic. So in this way, it becomes more secure and also it is more maintainable because whenever you would like to do some change with respect to order service, we are going to touch only the order service. We are not going to touch on the payment service. And the next principle is dependency inversion principle. This also we have ideas throughout our class. So dependency inversion principle, like so the clients or the application who is accessing the service, they should only have the idea about what kind of services are available. They don't need to know the internal logic. So how can we attain this? We can define some higher level modules and lower level modules. Higher level modules will define the abstraction and the lower level modules will define the conclusion of the abstraction. So, and this service can be exposed through the higher level modules. This principle can be applied to the microservice. So whenever you are designing a microservice, and we can follow this principle, like we can define some higher level service and some lower level service, and uh, the client, whoever would like to access that service, can access through the higher level service. It makes more secure microservice. And next, we are going to see about the object-oriented language features like encapsulation, polymorphism, and inheritance. How we can apply these features while designing the microservice. So, encapsulation. We already know that in object-oriented programming language, so whenever we are designing a class, it encapsulates all its internal property and functions as a class, and it will be exposed through the object. And if you are defining the properties as a private property, then it will not be exposed to the outer client. And it can be accessed to the logic through the published public methods. So that is what encapsulation. Similarly, whenever you are designing a microservice, all the implementations are done inside the service and it is exposed as we already know through the abstraction or interface or API gateways. So the outside people they don't know the internal logic. So the service the logic of the service is encapsulated inside a service. And the next one is the polymorphism and inheritance. In this case, as we already seen through the dependency inversion principle, the same thing can be followed here. Like we can define the higher level classes and lower level classes. The higher level classes will have abstraction, and the lower level classes will have the conclusion of the abstraction. Like it will have the implementation of the methods which are abstracted in the higher level. So if you are taking example for microservice, consider this catalog service. At present, the catalog service is showing some menu items. It can be the regular menu item. Suppose in the future, the client would like to add the other kind of catalogs. Like we would like to create a separate catalog for online and some catalog for festivals and some catalogs which is available only for the weekend. So they would like to create these kind of catalogs. So in that case, we can create these catalog and make them to follow this catalog, the regular catalog service. And then inside logic, whatever catalog or menu items you are designing for this online catalog will be useful only for the online customers. And here inside the festival catalog, we can define the menu items which will be available throughout the festival time. And the weekend catalog will have the menu items which is available only in the weekend. So in this way, this microservice, that is the catalog service, is becoming scalable. Like we are able to add the new features. And then UML diagrams for microservices. So here we are going to see about how can we use the UML diagram to capture the microservice design so that the microservice will be it is more it is having all the information about the application. So how can we do that? First we are going to see about the use case diagram. So under use case diagram, on the right side diagram it shows the use case diagram for the restaurant application. So left side we have user on the left side, and on the right side we have the other systems who is interacting with the restaurant application. So if you see the user, he can go ahead and create a user profile. He can browse through the catalog items. He can order for the food, and he can also avail the dining service. He can do the payment for the order or for the food he has taken. He can also make use of the delivery service which is provided by the restaurant, and he can also give the feedback. So these are the possible functionalities for a restaurant application. So by using this class diagram, we can capture all the needed functionalities for a particular application, as well as we can capture like who are all the actors going to interact with this application. So in this way, whenever we are using the use case diagram, we have the higher chances of capturing all the functionalities of the application. We don't have chance to miss any of them. So this is the use case diagram for the restaurant application. We can also design the use case diagram for a specific use case. So if you see, each of these use case is focusing on a particular function, right? So each of these use case can be implemented as a service. Inside the service, we can define what are all the logics it has to do. So, for example, if we take this order food use case, and we will design the use case diagram for making an order of the food. So inside the order, we can have the functionality. We should be having this functionality to create an order, updating the existing order, and to delete the order, and to find out the order whether it is existing or not. So as well as whenever you are making an order, there are chances to make the payment through online. So in that case, we need to generate the bill, and we should be getting the status for the payment. So these are the possible functionalities which has to be implemented inside the order management service. So when you are designing this use case diagram for a particular microservice, ensure that we will capture all the functionalities needed for that particular microservice. And so it gives a clear idea for the developers like what needed implementation they have to do for this particular service. And next one is class diagram. So for the same order service, which is explained in this use case diagram, we will see how to create the class diagram. So for this example, I have taken the string microservice design. In that we will be creating some classes called the controllers, and we will be having the services. We will have the repository and entity. So the implementation, the services which are all being supported for the order management system, uh, all those services will be exposed through this controller. That is, the API gateway endpoint will be defined through this controller. So whenever the outside application is trying to access this order service, it will start its uh, invocation from this controller. So this controller in turn it will contact with the order service, or it can directly go and access some record through the order repository, and this order repository will work with the order entity to fetch the order data, and then it will return that particular data to the controller. Similarly, when the controller is accessing the order service, it can either interact with the repository in order to fetch the DB data, or it can sometimes it can contact with the third party services that can be done through the order service implementation. So through this implementation, it can contact the third party services. So once it receives the response, it will be returned to the requested client or customers. So here, for this order service, it will be exposed through this service registry. So whenever we are creating a microservice, it will be registered in the service registry, and then the client can access the service through the service registry. I mean, the client essentially will invoke the instance of the service through service registry. And next one is deployment diagram. In this diagram, we can see the uh, runtime, the deployment view of the application, like how the application can be deployed, and we can make the application more efficient. So if you see, we are taking the same restaurant application. On the right side, we have four number of servers, and each of the server has a specific services deployed into it. So in the server one, we have the customer and order microservice deployed, and both of the services sharing the same database. Since they are working together, we are sharing the database between the customer and order. And then in the server two, the feedback service and notification service is deployed, and each of them interacting with their own database. And in the server 3, we have the payment service deployed, and it is interacting with the payment DB. In server 4, we have the catalog service. It is internally interacting with the catalog database. All these services will be exposed to the interface, and then these interfaces can be accessed through the API gateway. There can be API gateway which will support the web browsers, and there also be API gateway which is supporting the smartphone applications. So by designing this deployment diagram, we can have the higher level deployment view of our application. So whenever we are designing this diagram, we will come to know what are all the elements involved in this application, and um, we can also note that if there is anything, suppose there might be a need of interacting with a third party service, so that need to be included in this deployment diagram. Like whenever we are looking at the higher level, we can add what are all the elements needed to make this application functional. So coming to the conclusion, so we have seen some solid principles and some of the object-oriented design features like encapsulation polymorphism, as well as we have seen the class UML class diagram and use case diagram as well as the deployment diagram, how they can be used to design the microservice. And by following these rules, the microservice is becoming more maintainable, reusable, and scalable, and more secure. So if we are following these principles whenever we are designing the microservice, I'm sure that the microservice will be more efficient and more evolvable. And here I have listed some of the reference which I have used for this paper. If you have any questions, we can discuss through our class. And that's all. I'm done with my presentation. Thank you, guys.